which includes the whole region. Understood this? Clear?
Yes, sir.
Now, in case of an isolated conductor, when you give charge on this, the field lines will move up to infinity. No? Okay. Here, the reference is infinity. No? V of A with respect to some reference. This is only we take like this. Usually we take infinity as a reference and we say. So when I say V, it means this. Okay. So here Q is C of A, V of A. This is only Q. This is C of A into the V. Understood this? Is it clear?
Yes, sir. Clear.
Yes.
Okay. Now suppose return this. Completed.
Yes, sir. Completed.
1 minute, sir.
Completed, sir.
Completed.
Yes,
Now
sir.
you are having two bodies like this. Okay. Now I removed some charge and I have kept here. Understood this? Followed. That means I have given electrons to this. So this will become what?
Negative.
Negative charge.
That means I have given here electrons. So this becomes positive, no?
Yes.
Now you can see there are field lines, no? The field lines, as usual, is the field line. Understood this? Now here, this is A, B, no?
Yes.
So here V refers to V, nothing but potential of A with respect to B. Understood this? Then this
Yes.
capacitance, this is called as mutual capacitance of system of conductors A and B. Understood this?
Yes, sir.
So this is the system of conductor. Understood this? So here charge. This is suppose I give electrons here, q electrons. So if this is plus q, what will be here? Same, no? Minus q.
Minus Q.
So we can take charge on A. This is mutual capacitance between this. This is q capacitance. We write like this, and C equals q by. That means we'll generally write it as positive minus negative. Understood this? Is
Yes,
it
sir.
clear?
Yes.
Clear, sir.
Pardon. Shall I turn this?
Sir, 1 minute, please. One. Yes, sir. Complete.
1 minute, sir. 1 minute.
Finished?
Mm. Sir, one doubt, sir.
Yeah.
Sir, can capacitance be negative, sir?
Pardon?
Sir, can a body have negative capacitance?
Capacitance means what? Charge holding ability. That will be either
Yes.
zero or it can hold some charge. Negative capacitance means it should not, cannot, it will be giving out charge. No? Is it possible?
No, sir.
Then capacity of a water bottle 1 liter. Can you have minus 1 liter water bottle? Huh?
No, sir.
Then
Yes.
Yes, sir. Understood, sir.
Done, sir.
follow this.
Followed,
That's
sir.
why to avoid that only we are taking charge on positive plate by potential of higher minus lower. Q is charge on body which is at higher potential. Understood this?
Yes.
Clear?
Yes, sir.
Clear, sir. Clear.
See here remember do you agree with this?
Yes, sir.
Follow this. This will always be positive, no? Is it clear? Right.
Clear, sir.
Now you can see that VA Remember this?
Yes, sir.
Understood this? Should I turn this?
Yes, sir.
Yes, sir.
One minute, sir. 1 minute. Yes, sir. Completed.
Finished?
Yes, sir. Complete.
Okay.
Yes, sir.
Suppose a charge is supplied to it. In surrounding, no? Agreed. Do you agree with this?
Yes, sir.
Now you can do like this, no?
Yes, sir.
What is E?
2 pi epsilon.
Do you agree with this?
Agree.
L and R, no? R square, no?
Sir, ask me.
1 by x square, sir. Yes, sir.
Do you agree with this?
Yes, sir.
Minus minus will become plus, no? Till here already you learned many times. Agreed.
Yes, sir. Sir, one doubt, sir.
Yes.
Sir, Q by 4 pi epsilon now, sir. 0
Epsilon.
to epsilon. Yes,
This is
sir.
epsilon only.
Yes, sir.
Okay. So you have capacitance charge by the potential on the surface. Is it clear?
Yes.
Shall I turn this?
1 minute, sir.
Understood this?
Yes, sir.
Is it clear?
Yes, sir. 1 minute, sir.
Done, sir.
Completed?
Yes, sir.
Done, sir.
Any doubt?
Road, sir, road.
No doubt, sir.
See, suppose this is sphere. Okay, so there is a charge on this is Q. Now this is surrounded by only to some extent. There is a medium. After that, it is vacuum only. Then how to solve this? I'll give an idea. Inside this, if you take, what is the electric field mean?
1 by 4 pi epsilon naught r, where h by q by r.
Okay.
Sir, vacuum na, sir. So we can take epsilon naught now.
Hmm?
Vacuum only na, sir, inside.
This is not vacuum, man. This is medium. This is conducting sphere. Okay.
Yes.
Understood this?
Yes, sir.
So now E1, it runs from where?
Yes, sir.
Again, you to consider this one, from where this on the surface. Understood this? Get
Yes,
V.
sir.
You can integrate this now. Can't integrate, substitute this.
Yes,
Sir,
we
E2
can.
is 1 by 4 pi epsilon not Q by
Q
X
by
square,
X,
no, sir.
X square.
You can integrate this now.
Yes, sir.
Because integral of dx by x square is nothing but x power minus 2 dx. Substitute the upper limit minus lower limit. Do it carefully. No. Hello?
Yes, sir.
May I answer?
V minus V infinity is equal to Q by 4 pi epsilon naught into 1 by R1 epsilon naught R
V infinity
minus
is
infinity is 0.
good.
Yes, sir,
Got this.
got.
Shall I turn this?
Yes, sir.
1 minute.
Take LCM. Got this?
Yes, sir.
Now, what is the capacitance of the system? Charge on that by
V.
potential, no? With respect to infinity.
Yes, sir.
Sir,
Hmm.
sir, we get V equal to minus Q by 4 pi epsilon naught into 1 by R2, sir.
It's correct or no? Here is one
Correct,
minus
sir.
D. Check up
Yes, sir.
carefully.
Sir, down one correct, sir. After LCM, I got this only. But, sir, in the above, we will get Q by 4 pi epsilon naught into 1 by R2, sir. That term we will get in negative.
No, sir. It is correct only, sir. I
Positive
got
only, sir.
Only, sir, correct only.
Check up pen once again. See, suppose this is only K, no? Here only other name is K. Relative permittivity or dielectric constant. See, if K is 1, it is totally vacuum. What you will get V? See, this is 0. This will K will get cancelled. So what is get? 4 pi epsilon naught
No.
R1. Same thing what you got previously, no? See, previous question, if you take K as 1, you'll get the same thing. See, understood this?
Yes.
Yes, sir.
Shall I turn this?
1 minute. 1 minute.
Sir, taking V infinity as 0, we get minus V equal to this term, no, sir?
Do it, man. Check up.
Sir, you wrote positive V, sir. There V infinity minus V will be equal to Q by
That
epsilon naught.
negative
This
and
man,
the
this
RHS negative
minus.
will get cancelled.
Check up, man, once again. Shall I turn the page?
Yes.
1
Yes,
second.
sir.
Done, sir.
Shall I turn this?
Yes, sir.
Yes, sir. Completed.
So they should have equal and opposite charges. Understood this?
Yes, sir.
See, the charges on the plates of a capacitor are equal and opposite. the charges plates means conductors.
Yes, sir.
The system still will have a capacity. Okay. Understood this?
Yes, sir.
Sir, one doubt, sir.
Still.
So this at last you told now, sir, system still will have a capacity if
Hmm.
plates have
Hmm.
some different charges.
Hmm.
Sir, by capacity did you mean capacitance, sir?
Pardon?
So by this
Capacity means for every conductor, a system of conductors, the charge holding ability will be there. Okay, but if the plates have equal and opposite charges, that means field lines should start from one and terminate on the other. Then we call that as mutual capacitance. Understood this?
yes, sir.
Every system has capacity.
Sir, I ask this because in this equation, no, sir, magnitude of charge on a plate, sir,
Hmm.
it should be equal, no, sir. Then only we can use this, no, sir.
Pardon?
Sir, this charges should be equal on both plates, no, sir. Then only we can use this magnitude of charge on a plate, no, sir.
That's what. That is only for
Yes,
this, no?
yes,
For
sir.
this only I gave that.
Yes, sir. Understood, sir. Clear.
See, suppose you are having a situation, this is one conductor, this is the charged one. When you bring an uncharged here, is uncharged. Neutral conductor, when you bring, what will happen here? This will induce negative. Suppose this whole thing is Q. Is zero only, no?
Yes, sir.
Yes, sir.
So here you can see Q is, here Q will be zero, no?
Yes, sir.
Agree or not? Clear?
Clear, sir.
See here, all lines of force will not go over here. These lines of force, because here it won't know. So some lines of force will go away like this. If all lines terminate on that, then we call it as a capacitor. Understood this?
Yes.
Yes.
So here also capacity is Q1, capacitor of this now. Agreed.
Agree, sir.
Completed?
1 minute.
Sir, 1 minute.
Completed, sir.
Done, sir. Done, sir.
Completed, man.
Yes, sir. Complete.
No doubt. Visible?
Yes, sir.
Completed?
So 1 minute, sir, please.
Completed?
Yes. 1 minute, sir. 1 minute. Last line. Done, sir.
Finished? One by one we'll show. First one, the two conductors which are concentric. Inner is given a charge, it seems. So let the charge given to this be some plus q. He gave that one, no?
Yes, sir.
Where does it reside?
The outer surface.
Understood this? Now, what does it do? It induces. Net induced charge is zero, no?
Yes, sir.
Agreed. Outer is earth. Okay, when outer is earth, what will be total charge will be? This will be QE. Agreed? This charge will there will be charge exchange between these two, no? Do you agree with this
Yes,
or not?
sir.
Yes, sir.
What is the potential at the outer sphere?
0.
0.
Okay. What is V1? Due to this charge, agreed.
Yes, sir. This.
Next, that's all, no? Any doubt? Already we have done this.
Yes, sir.
Yes, sir.
That means finally the system will be having Q minus Q here. This is 0. That means the lines of force that start from here, they terminate like this. Agreed?
Yes.
There won't be any field here. Will there be any field outside?
No.
Why? Because no charge, no?
Yes, sir.
No charge.
Now, if you take the Gaussian surface somewhere here, for this Gaussian surface, let E be the electric field at any point. E into, let this be ds cos 0. The charge enclosed is this. This is free space, epsilon naught. Suppose as a medium, you should take epsilon. Okay. So here, so what is the electric field? Is it clear? Now we can say that dV if you take this as 2 V2 x is a. V1 is 0 now, already we took this point. No? Agreed. Find out this. You should get this, see.
Got it, sir.
Got it, sir.
Hello, you got this? Hello?
Sir, do one, sir, please.
Do, man. Do.
Yes, sir. Got it. Got.
Got this?
Yes, sir. Yes.
Now you can see now the charges on the plates are equal and opposite now. Understood this?
Yes, sir. Q and minus Q.
Now how do you define charge on any one plate by potential difference between them, no? Remember this?
Yes, sir.
And see how much you are getting. Got this or not?
So one doubt, sir. Sir,
Okay.
after earthing, both will have different charges, no, sir. Both
Okay,
conductors.
finally what you got, man? Finally,
Yes, sir.
Q
Minus Q
minus
minus.
Q.
Yes, sir. Yes,
Yes,
that
sir.
Now
was
you can see this we learned previously, earthing, what to do. Gauss law.
Yes.
You can see there's a continuous flow from starting date till now. Everything is interconnected. Great. Similarly, when you go to higher class also, this interconnection will get carried. That is the reason why they'll keep the syllabus, no? Otherwise they can keep history or economics, no? Why they keep only physics, no? Tell. Just for fun degree, they'll keep. Fun, you can do anything. You can start history, physics, chemistry, or history, economic, maths. That is only fun study. But you don't have any professional knowledge to enter into job scenario. You want to learn physics, suddenly jumping into middle chapter. Main problem for many students is when classes begin in the beginning, units and dimensions, basic maths, vectors, all that people will take lightly. They'll come from 10th only. No? Till then they'll play ringer was all that they played. Pampering, question answer. They'll take what is there. So after that, kinematics little bit. Newton's laws are not, everything will be blank. Total paradigm shift, no? The student is regularly attending, doing the work sincerely. Definitely God will bless. Now, otherwise, I will pray God, man. You are also doing work by praying, no? So that work means energy should be supplied, no? Energy is conserved, no? If you work only, that energy will be returned back. Shall I turn this? Go to the next one. So the system is what? Capacitor.
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 Now see, if this plate, shall I turn this? Now
Yes, sir.
suppose the outer B goes to, in the above question only, B tends to infinity. What is that you have? C tends to what? See? Capacitance tends to what? See? Hopeless fellow. Don't know?
4 pi epsilon naught A.
This is nothing but an isolated conductor. Now B is infinity means the other end is what? Infinity only, no?
Yes, sir.
Okay. Agreed? Understood or not?
Yes, sir.
Understood this?
Yes, sir.
Yes, sir.
Is it clear? Any doubt is there?
No doubt, sir. Clear.
Now let us go to the second part. Can you do it? Same story,
1
no? Do
minute.
it.
Done, sir.
Second part.
1 minute, sir.
Finished?
I completed. Yes, sir.
In the second case, shells are charge is given to what?
So P
Charge is
out,
given to this.
outer space.
This is earth. When it is earthed, what will be here?
Potential is 0.
Agreed?
Yes, sir. Agreed, sir.
Tell what is the potential of inner sphere?
0.
Due to discharge at this point, due to discharge, what is that? At this point. Agreed?
Yes, sir.
Due to this. What is QA? Agreed?
Agreed, sir.
So what is the final charge distribution?
Plus Q.
So what is the field between the shells? Charge enclosed. Agreed? Now at this point, this is x is equal to b, potential is v. X is equal to a, potential is 0, no? Here.
Yes, sir.
Find that potential. You will be getting this.
Sir, one doubt, sir. So this E is equal to 1 by 4 by epsilon 0 QE by x square, no, sir? QE by x square. Yes,
QE value substitute. What is QE value already got? Substitute it and do it carefully, you should get this.
yes, sir.
Got it, sir. Got it, sir.
Got this?
Yes, sir.
How much you got? This one? Got this? So you can take the capacitance, no? See, charge given by potential of that with respect to the other. Understood it? Clear or not?
Yes, sir. Clear, sir.
I'll turn this. Shall I write this?
1 minute, sir. 1 minute.
Finished?
Yes, sir. Completed. 1 minute. Completed, sir.
See here, okay. Understood this? Do you agree with this or not? Understood
Yes, sir.
this?
Understood, sir.
How much you're getting? 4 pi. What is?
Sir, doing, sir. 1 minute. Got this.
Not getting.
Sir, got this, sir. Got this.
Understood this?
Yes, sir.
This has a capacity, but it is not called a capacitor. For capacitor, what is the condition? The two conductors must have equal and opposite charges. In that case, the capacitor is defined as charge on any one plate, magnitude of the charge on any one plate by potential difference between the plate. That means higher potential minus lower potential. But in this case, the charges are unequal. It is not a capacitor. If it is not a capacitor, also it has a capacity. How to define that capacity? Charge given to a conductor by potential of that conductor with respect to the other. Is it clear?
Yes, sir.
Yes, sir.
Shall I turn this?
Sir, so in this case, we have to calculate the capacity of both the conductors separately, right?
Here, which
Yes,
case?
sir. This one, sir. The
Third,
one which
third,
is
third case.
no, sir. The one without the capacitor.
This one.
Yes, sir. Yes, sir. In this, we have to calculate it separately, right?
Calculate.
Calculate the capacity of both the
Here,
conductors.
I found no. I found no. No, this is the capacity of the system.
Okay, sir. Yes, sir. Yes, sir. Got you, sir. Never mind. Never mind. Yes, sir.
Understood this? There is not an isolated conductor. Another conductor is there, means you will have capacitor system.
Yes, sir. Understood.
But the system is not called a capacitor. Isolated conductor, then two conductors which are bounded by some field, but the charges are not same. That is also having a capacity, but it is not called a capacitor. Okay, every such arrangement has capacity. And if the plates have equal and opposite charges, then that system constitute a capacitor.
Capacitor.
Understood this? Otherwise, it is not a capacitor.
Understood, sir.
Shall I turn this?
Yes, sir.
One more part is there. See? Shall I turn this?
Yes, sir. Completed.
The third part. What is the third one? There are two spheres. Equal and opposite charges. Anyway, you can take. There's a capacitor. No, the system is capacitor, not.
Yes, sir. Has.
This system is a capacitor. Okay. Now, as usual, what we should do? Find the electric field, no, at any point in between. At a distance of r. How do you find the electric field using Gauss law? Take on sphere here. Tell. Or from here to here, directly on sphere, now how much you will have? If you keep plus one charge, it will go like this now. This side.
Yes, sir.
This will also go this side, no? Do you agree with this?
Yes, sir.
You want from surfaces only, no? R will be how much?
Yes. Yes, sir.
Then on the surface of the other, if we take R is d minus b, no? From here to here, no? You can integrate this. See, integral law I'll do for this.
Sir. One doubt, sir.
L.
B minus B plus, sorry, minus A also needed, sir.
Minus?
Between them. Sir,
From
last,
here you are taking, man. R runs from here to here, no?
uh, so
On the surface we want for that, what is the value of R? At this point,
yes,
what is the
sir.
value of R?
A.
At this point, R equals small a. At this point, R will be how much?
B minus
Followed
B
there?
minus. Followed, sir. Followed. Correct.
Understood this integration? Remember this? You substitute this. Can you substitute other integral also? You'll get.
Yes, sir.
Got this?
Sir, doing, sir. 1 minute.
Excuse me, sir.
Tell me.
Sir, I still have that doubt, sir. How you are taking R is equals to D minus B, sir?
R is starting from here now.
Yes, sir.
We are taking a point here now.
Yes, sir.
From here to here, what is the distance? This is a D. Remove
Yes.
this. You'll get this now.
Yes, sir.
This
Yes,
is
sir.
one
Understood.
point I am taking, another point here, man.
Yes, sir.
You should teach me, man. You're all maths people now. I'm a small physics teacher. Hmm? Shall I turn this?
So 1 minute, sir, please.
Done, sir.
Completed? Got this?
Sir, do
Done, sir.
Shall I turn this?
Yes, sir.
Got this?
Yes, sir.
How do you define? Positive minus negative potential, no? Got this?
do
How much should this? See?
Yes, understood.
Agreed.
Agreed.
Not getting that?
So got the potential difference. Yes.
If the distance of separation is far greater than A and also B, agreed.
Yes, sir.
In that case, what is the capacitance? Minus 2 by D you'll get. Agreed?
Yes, sir.
Sir, in VA minus BB is equals to you wrote Q by 4 pi epsilon not A, sir. The A should not come there, sir.
Huh?
In up there you wrote VA minus VB is equals to Q by 4 pi epsilon A, not A, sir. A should not come there, sir.
A is not there. Huh?
Yes, sir.
Any doubt?
No,
Any doubt is there?
no, sir. Clear, sir. Clear.
No, sir. Sir,
So after
yes.
the class, start working and you can start doing that to drive capacitors. Simple problem. Huh? One or two you'll get.
Yes, sir.
Right. We'll meet tomorrow. Then. Okay. Right.
Sir, thank you, sir.
Thank you, sir. Bye, sir.
Sir, bye, sir.
Thank you, sir. Bye.
Bye. Bye.